Hey Guildies, Fletch here. Today I'm going to start talking about the Maybe Monad, some implementation details about it. Feel free to ask questions in the chat while I'm talking about this. This is sort of a continuation of a previous talk that I did that sort of introduced people to the Maybe Monad, some evolution of code that people might go through, the mentality they go through whenever they're changing their code from an old object-oriented style of using of programming into using the Maybe Monad, and sort of how that evolution, the mental evolution, happens from that. And so this one I'm going to actually be using the Maybe Monad and some of its implementation, some of its functionality, so that we can see what benefits they are. So a lot of times people ask me, what's the point of the Maybe Monad if C# now has the nullable ability? Because a lot of times when people talk about using the monad in C#, and I know my lighting's a little bit weird here, but I don't know why. A lot of times when people are talking about using monads in C#, they say, oh, it's great because it replaces the need for null or something like that, in a very generic statement. But while the nullable thing in C# does a lot, there's also a lot more than it does than that. There's actually three goals that all sort of just come down to the goal of use the Maybe Monad. So I'm going to go ahead and drop over to my screen. Bam. And remember, there's about a 20-second delay from you to me and then from me to you. So if there's a question asked, then keep that in mind. Okay, so I'm going to start here at the very back of the code. Monads are inherently stuff that gets passed along as the return value in your code. So they start in the deepest code, they get passed back and used, they get passed back and used, they get passed back and used. It's not so much something that you pass into a parameter list. So you don't like start your code with a monad and then pass a monad into a function and then just pass that really deep down and then use the monad. So since it happens in the other direction, I'm sort of starting the deepest part of the code here. So the deepest part of the code, this is like a repo, for example. It's some repo, very descriptive. And in this some repo, I'm just sort of mocking out some things that you might do in a repo. Your method could be doing a lot more than this. It might be a lot more simple than this. But simply put, you have your DB context if you're using Entity Framework, or you have some sort of a SQL connection or something, or using Dapper, whatever you're using. You start with some kind of a query. You might be saying, await query async, or you might be whatever it is that you do in query. In this case, you'd be getting back an iQueryable if you're using an ORM like Entity Framework. You might be adding to the iQueryable. You might be doing some conditional stuff in here. In the end, once you actually evaluate and pull that query, after you've generated your query, you've done all your stuff that you want to do, you then eventually evaluate that query. It sends it off to the database sends back and returns to you null, or a DB null, or some sort of exception. Whatever happens, you're getting back something that you don't like. And in the case that you get back something you don't like, if you check for it yourself, you handle it yourself. Or if it's something you really didn't expect, it throws an exception, then you handle it within the exception. Either way, the result of what you're doing is you're either going to end up throwing an exception, because that's just the way that you do your control your code flow, or you're going to end up returning null, because that's how you do your code flow. Or maybe if you really do avoid that and you use the in my last video I talked about how the evolution, and one of the parts of the evolution is like the try paradigm. So maybe you returned false. You returned false here, and then your sum entity would end up being an out sum entity, and this would be a Boolean. But you're controlling your code flow in these sorts of ways, mainly by returning null or by throwing an exception. And so null would mean that nothing was found. We tried this, it didn't work, nothing was found, so we return null. It sort of makes sense to somebody who does this a lot. As me, I do that a lot in code where monads aren't used very frequently. But of course, if result comes back with something, you return result. So this is just perfectly normal code. This is code that everyone sees most of the time in their life and back in the repository. This is a service, so this is like a domain layer business logic service. This is the thing that's consuming the code, and these are the types of problems that we're trying to fix. I'm not saying do these things. I'm just saying these are the things that you see a lot in code, and these are the things that we're trying to find solutions for. So another thing that we're trying to find a solution for here is once we get that thing back from the repo.get item, then that thing, we're going to have to check if it's null. If it's null, then maybe we'll do some sort of domain handling. Maybe in the repo handling, I do a rollback or something. But in the domain handling, maybe I log something, or maybe I handle this in a different manner. And maybe I return null, maybe I don't return null, maybe I continue, maybe I can continue on. I don't know, there's going to be some different conditions that you can do. But I definitely want to wrap this in a try catch. Because when I'm calling out to a repository method, I can't control that. I don't know what's going on in the repository method. All this says is that it's going to return some entity. It doesn't say try get item, which would guarantee, contractually guarantee anyway, that it's not going to throw an exception, or some entity. It may return a some entity. It may be null. It might throw an exception. So there's a lot of things that could happen with this. And generally speaking, you want to wrap those external calls, SDK calls, or calls out to data repositories and try catches. This one's a little bit built out, but I'm trying to keep this code as simple as possible. But I'm just trying to say, when it comes back, you do want to check for null and possibly handle that. Maybe return null, maybe something else. You do want to check for exceptions, catch exceptions, and handle those, and possibly return null, maybe not. It's going to depend on your code. So there's a couple things that I want to do here, which are completely arbitrary for this code, but it's not stuff that you wouldn't see in typical code. So I'm gonna check if the num or something. There's nothing special about this entity. A couple of fake properties on here. I'm gonna check if it has a value, because this num or something might be null. If it doesn't have a value, if it doesn't has value, then I'm gonna return no num. You don't have to memorize this or anything, but no num is the thing that I want to return from this. If num or something equals 0, then I'm going to throw an exception. You can't divide by 0. Something happened with the way that I got this data. This is just how the business logic wants to happen. We just want to throw this exception. Can't divide by 0. We definitely don't want to continue on. And then if we get through these things, then I'm going to say we're going to pull that number out and we're going to use that later on. I only put this here so that I can sort of group this together in one little section and not have to reference this again later on. So same thing here, not there, same thing here, but for the date. So we have some sort of date time. If it doesn't have a value, we return there's no some date. And then if the year of the date time, so it has a value if you're down here, the year is greater than or equal to 2000, it's within this century. Otherwise it's last century. So this is another thing that I'm doing. And then here we have the year. We're just calculating the year, just pulling the year off of some date dot value dot year. We know that there's a year because we've already been through this, and year is actually an integer, not a nullable integer. Then the last thing we do is we have this calculation and this string transformation, and we're putting it concatenation, string concatenation. So the last thing we're doing is putting it together like this. So this is not a super abnormal thing. You might see this, you might not see something exactly like this, but you see code like this in the wild, and it makes perfect sense. So let's go from basic-ish repository, basic-ish solo service here that just sort of does the things that it needs to do inside this method, and then let's go into this refactored method. So this refactored method now looks like this. In this refactored method, I'm still doing this try catch here because I'm still using the repo.get item. But the rest of the method has been refactored so that we can have those different steps. So we have the one that validates the number and then eventually results inside the integer. And then we have the thing that validates the date and then results in some string that says, it's this century or it's last century. And then we have the thing that pulls the year. This is actually exactly the same as the last one. Then we have that part at the bottom that did the string concatenation, the calculation and the string concatenation down there. So all I've really done is I've pulled those out into their section. I've refactored it. This is the refactored service. It ends up being about the same number of lines plus an extra line or two for each space here and the method signature and stuff like that. But it's about the same number of lines here. And the functionality is exactly the same. So nothing's really changed other than this is arguably more readable than the other one. So that's great. We're moving in the right direction. But let's look at the testing. I'm not going to look at the testing for that solo service. I'm going to look at the refactored services testing. The testing is very, very simple, as you can imagine. Maybe you know this, maybe you don't. But since I've created those functional pieces as their own methods, I can just directly call those functional methods and those pure methods and say, I'm going to validate this number. The number gets validated and returns actual, and make sure that those are the same things. Here, only because of the way things are happening with having to catch exceptions and all that stuff, we need to validate this num. We need to say validate num 0 because validate num throws an exception if it doesn't have a value or if it can't divide by 0, something like that. We have to throw an exception. So now we have to write our tests such that they're checking for exceptions. In other words, we're still using exceptions as our code flow for some things, so we have to test against that. That's one of the things that we want to get away from whenever we're using the maybe monad, which we're going to get into in the next portion. So and same thing with this one, null throws. This one, it's a recent, it's in this century, so we want to make sure it says within century, last century, and this is the result of that string concatenation if it's this versus if it's this. I know that I could have used a lot of other functionality in XUnit here, but I wanted to write these tests out very explicitly to show that I've got the same tests for the refactor tests, which is this one right here, for the solo class, and for the functional core style testing. So testing is really, really simple. But let's go back to the solo tests. In order to test this solo service here that has all the stuff inside of one method, it has not been refactored out. How are we going to test this? We actually can't test. I had this skip because they wouldn't pass anyway. I sort of wanted to walk through this a little bit with you guys. So in order to test this, we have to have a reference, an actual reference. It's not static. We have to have an actual reference to a concrete class, concrete instantiated class. So we have the solo service. We had to create a mock repo because in order to get the details all the way through all of the different lines of this one method, we have to mock everything out. So we have to mock out the repo, and we have to do things with an ID. We have to actually call the single method here called do things. And then how would we test this? So previously, we just said this is expected. We pass it in and we validate the number. And so we want to make sure that this validate number does what we expect it to, a very limited amount of functionality. But in order to test this bit of functionality, which is this portion here, in order to test that, we have to go through the whole method. And we actually never get the result of this little bit. But the result of this little bit does end up being part of this calculation, and part of this calculation will be here. So in order to test this method, in order to run the same exact test, we have to parse apart what the actual thing is, get the number out of it, and then do sort of like a reverse calculation to see what what it had turned up with. So the actual ends up being that parsed apart piece at the end, and then what we're expecting would be something like we are expecting this, but that's so much work, and so I'm just sort of trying to impress upon you at least the part about separating your imperative shell from your functional core. So we're doing a ports and adapters style thing called functional core imperative shell. I say imperative shell functional core, either half a dozen. So if you split your code apart such that you have this here, which has no logic in it, this is a guard clause, so I don't consider that logic. This is just a call, 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 and it returns. Nothing that it really needs to be tested here. But down here, this is definitely some conditional transformations going on down here. Lots of transformations, conditional transformations. These are things that need to be tested. So we've at least benefited our code by splitting out the functional pieces from the imperative pieces. Okay, now let's go on to the maybe repo. So this is my first time in this code base using the maybe repo. So I'm going to be doing the same thing here. Okay, this is the repo, so I'm going to talk about the sum repo. So this is the sum repo. This is before using the maybe monad, where I just returned an entity, and these are the things that it does. I'm returning null, or I'm throwing an exception, but in order to get away from that, what I'm actually doing is I'm returning a maybe of some entity, which is something I talked about in the last video. So if you don't know what a maybe monad is, then the last video is something you need to do. But what I'm essentially saying is maybe I'll return a some entity, maybe I'll return nothing. There might not be a some entity there. And I'm going to communicate to the caller of this method whether or not I am passing back a some entity, or whether I am or whether I'm not passing back a some entity. So in this case, I'm using something that's part of the GenStudios library. This isn't in every monad. I'm just called the try. And this does the same thing as a try catch. Actually, can I go to the implementation of this? Okay. So yeah, it just tries to do the thing that you tell it to do, which is actually the same as the last method. Very, very similar to the previous implementation. So it says try to do the thing. If an exception is thrown from that, then it creates a maybe.none. It's a non-maybe. It's an empty maybe, and you can handle that however you want. So I can put all kinds of handling in here if I want to, but I'm just assigning a message to it. There could be whatever other handling rollbacks and stuff that you want to do in here. So that's just a try implementation that the GenStudios library has. But the most important thing is that inside my implementation here, I am trying to get from the data source, just like the last one. I'm doing a bunch of stuff that I think I need to do to it. Maybe making multiple calls to the database, or joining some things together, or changing the iQueryable. If it comes back null from the database, then I can handle that here if I want to, or I could and then I could return a maybe.none. So in my implementation of the stuff that I want to happen, I could be returning a maybe.none, because if it's null, I want to communicate back to the caller, I couldn't get it for you. This didn't work. I can't get this for you. And this is sort of goal number one of monads, of the maybe monad, is that instead of using exceptions to handle your code flow, you can just use the maybe.none. Now I'm going to show you how to handle the code flow using the maybe monad here in a second. But instead of throwing or returning null, I'm going to just say I couldn't get you one. And I'm just going to go ahead and return a nice message here. This isn't something that you should use for your code flow either. It's just sort of a human readable message. Then I've got, if it did work out, so this is like a guard clause, but if it did work out, then I'm going to say, okay, return sum with the result in it. And sum means I found one, and here it is. So this maybe.try ends up completing this successfully, and then just returning that maybe monad up through the repository. So this is how it ends up looking in the service, in the domain service, whenever your repository is returning a maybe monad. I can now say that the thing I'm getting is maybe get item, which was that implementation that we just looked at. And that maybe get item it'll never throw an exception. It'll never return null. So there's no exception checking or null checking or anything that I have to do here. I'm just saying that the thing that I was looking for in the repository, give it back to me. Now this might end up being a maybe that has something in it, or it might end up being a maybe that doesn't have something in it. It's not an anti-pattern, but it should be less common type pattern, that in order to get at that value, to be able to say thing.value, so var the real value equals thing.value, for example. Or if you want to say if thing.hasValue, then do something. And I have some of these patterns in order to keep things simple in my previous talk. I talked about some of these basic patterns, and I think that's really a way to ease C# developers into using the maybe monad, one step at a time. But I'm not easing it in here. Here I'm using the implementations as the monad was designed. So I've got the thing back, and now instead of just saying validate num, I'm saying bind. I'm saying thing with the thing that came back, because remember the thing has a number, it's got a date time on it, it's got a value, the date time has a year, it's got some other properties on it. So I'm saying thing.bind, and what bind does is it gives you the value. So instead of just saying .value, bind actually gives you the value. So you can see here, it's actually a sum entity. X here is a sum entity. So thing.bind, give me the value, and I'm going to do something with that value, and I will return back to you the result. Okay, so this is the validate num method that was happening before, where it makes sure. Let's just go to it. It'll Okay, yeah, this is obviously a different implementation. So previously we were throwing the exception if it doesn't have a value, or throwing can't divide by 0. So now we're saying if these negative things happen, return maybe.none inside of them. Otherwise, return maybe.sum. One of the rules of monads is that they have a return value, and the return value that means that you're going to be wrapping things in one or the other whenever you return a value. So you're either going to be returning a none, or you're going to be returning a sum. Now, actually, there's an automatic, I think I said this in my last video, there's an automatic boxing that happens for the Gen Studios one at least, and with a lot of other monads. So I could just say return the value that I want to return. It will automatically box it into a maybe.none, but I like to be explicit, so I'm going to be explicit with that. So this validate num here is returning another monad. So it's giving me the value of this thing monad. Here's the value, it's some entity. I'm saying, okay, I'm going to do something with this stuff, and I'm going to return to you another monad. So this isn't just the integer that we got previously. This is the integer wrapped in a maybe. And the same thing with the date. So the date, we're going to say that thing that we got from the repository, we're going to do a dot bind. So it's going to give us that value, that some entity value here, and we're going to do something with that, which is validate date. And this validate date is, just like the other one, it's no longer throwing exceptions or returning null. It's returning maybe.none if it doesn't have a value. Otherwise, there's two different possibilities of sum. It's either going to return sum with century, or it's going to return sum last century. Either way, it's returning a monad. So this date is no longer a string, just a string. It's now a string that is a maybe of type string. And the same thing with the year. So with the year here, I'm doing the try, which is, again, just a Gen Studios extension of the maybe. So I'm doing the try, and I'm saying return maybe.sum of that year. So once again, it's returning a maybe of type int. And in that case, the int is going to be the year. So we've just got a bunch of monads here. And because of associativity, we could, of course, move these things around. It doesn't matter what order that we put them in. And same thing down here. It doesn't matter what order we put these things in, as long as we start with the beginning and we end with the end. So associativity, if you remember general math principles, if A plus B plus C equals something, then A plus B plus C equals something. It doesn't really matter what order that you do the order of operations in. So here we have what we call the query syntax. So query syntax is something in C# where you can write, query syntax, just like sort of like SQL, structured query language. So query syntax, we can say we're going to select this int number from the maybe monad. So this is doing something a lot like a bind internally. This is because of the way that we have the monad set up, we can do this query syntax, and it's a lot like a bind, where we're saying we're going to bind to this monad, so give me the value out of it. We're going to bind to this monad, so give me the value out of it. We're going to bind to this monad, so give me the value out of it. And what I'm going to do is I'm going to select a finalize do things. And typically when you hear this, you see a query with select, what you think about in your mind is an IEnumerable. So typically when you do query syntax, you're saying, I'm going to go to a database and, given these different sources of information, these different tables, or these different lists, then I'm going to take them and I'm going to select something out of them. And so you're thinking it's going to enumerate and give you back a collection. So on IEnumerable, on the IEnumerable interface, you can do query syntax and IEnumerable of type string, for example. If these were all IEnumerable of type strings or objects, and then what I select is, again, an IEnumerable of type string, then what I'm going to get back is a list of strings or a collection of strings or an IEnumerable. I'm going to get back a collection. If you remember from my last video, a maybe, or a monad in general, is a collection of items. It's a collection that's either going to be 0 or 1, but a maybe is a collection of items. So what's going to happen here, since we've done all these binds, is we're selecting. If any of these end up failing, I didn't go over the fail, but that's okay. Let's say they get through. All of these get through, and what I get back, if typically it's IEnumerable, IEnumerable, IEnumerable. What you get back is an IEnumerable. Here we've got maybe monad, which is like a type of IEnumerable. We've got a maybe monad, maybe monad, maybe monad, and then let's return a value, which will then get put into a maybe monad. So what ends up getting returned is a maybe monad. So this actually generates a maybe monad. But again, since a maybe monad is 0 or 1 items, it's not going to give you an actual list of things. It's not going to give you 50 things inside of the collection. Unless this is a maybe of list of string, then something else might happen. But since it's just a maybe of string, this is going to be a collection or a maybe of string. So let me go back over what bind is here, because I sort of told you that bind will give you the value of the thing, and you can operate against that thing and return another monad. But what I didn't tell you is, what if the thing didn't have a value? What if it was one of those cases where it was null, or it threw an exception internally, or something like that, and a maybe.none came about? In that case, what bind does is it doesn't do anything, essentially. So I'm binding, it's saying give me the value. It only gives you the value in the case that there was a value, in case of has value, or in case a maybe.sum was generated. So in that case, you are going to be doing this if it's maybe.sum. If it was maybe.none, then what the bind does is it returns that maybe.none. So the maybe.none of this thing gets returned to this. If these are two different types, if this one is a maybe of type sum entity, and this is actually expecting a maybe of type int, then it'll convert, because maybes are functors. It'll convert from the one type to the other type. Maybe the value is lost because there's no value inside of a maybe.none, so the value is not there anyway. But in a bind, it will pass along, the error messages. It'll pass along whatever other state is inside the implementation of your monad, which should pretty much just be value and has value, but there might be more than that. But it'll pass that along into another maybe.none. Same thing with this one. If this thing had no value, then this bind will pass that along into this transfer date. And same thing with this one. If the thing had no value, it will just pass that no value into the year. So these essentially just don't get evaluated at all. They're just cast over into a different type of maybe monad. And then when they get evaluated, the instant that it sees the first one that says, well, that bind, the bind portion, the bind functionality, or the has value isn't there, then we're just going to cancel out and not continue on because there is no value there. And so it just converts it and it just returns a maybe.none. So all the steps get skipped once a bind is hit that has no value. So that's a huge benefit of bind, is you're not having to check for has value. You're not having to check for null or wrap things inside of a try catch. If there was no value, then let's just stop right here. There's no value, so let's return back whatever our maybe.none is. A lot of boilerplate is taken out of the picture whenever you do that. So this is one method using the query language, using the query syntax. Let's look at the tests for these, because the tests for these functional core written things with monads are going to look slightly different than the tests. These were the tests for the refactored one, and remember they were throwing exceptions. So, but they're going to look very similar, like especially this one. They're going to look very similar for the functional tests, almost identical for this one. But for this one, instead of checking that it threw an exception to handle the code flow, what we're going to do is we're going to say validate the number and pass it as 0. Remember, you can't divide by 0. And we're just going to assert that maybe.none returned. We could also assert that the human readable message was can't divide by 0 or something like that, but there's not really much value in asserting against just a human readable message. But we are definitely asserting that it was maybe.none. So the actual thing that came back for that maybe of type int ends up being a maybe of none. Same thing for this one. If we pass null into validate number, then maybe.none is what's expected, and that's actually what comes back. And then the same thing with these. They become really easy. In this case, this is not the human readable error message. This is actually the value. So the actual value of this thing, let me just show you again. There's a difference between maybe.none and providing an error message that is just a message that's human readable, versus the actual point of this method is to return a string value that has an actual value in it. So this is actually a value. It's not just some human readable thing. It's some, not that I'd say write code like this, but so we're checking the actual value, the expected value against the actual value here. And I mean, of course, all these tests pass. That'd be hilarious if I ran these 2 seconds ago and they passed, and they didn't pass right now, but there they go. Nope. Oh yeah, some of these are skipped. Like I said, these ones are skipped because I don't want to write those crazy complex tests. And I assert to you that the reason a lot of people don't write tests is because they're not this simple. The biggest reason why a lot of people don't write unit tests is because they're not doing test-driven development, and so they don't understand how simple things are whenever you have a functional core. You have these functional methods that are pure, and you write super simple tests against them, versus having to create all these mocks and then like go through a whole bunch of code and then hit something on the other side that comes out the other side and possibly parse that thing apart and figure out exactly. It's a nightmare. So I assert that the reason people don't do test-driven development or unit testing is because it's so complex because of the way that they write their code. So code testability is improved whenever you follow the functional core imperative shell patterns, and that is improved upon yet again whenever you no longer have to rely on throwing exceptions for your code flow, and you are instead using Maybe Monads. So first of all, Maybe Monads allow you to control your code flow better than throwing exceptions, and they also allow you to pass along the exception messages up through the stack, so that something at the very beginning, so the original caller, like of an API method, you can pass the exception reason all the way back to them and have a human readable message. That's not necessarily built into a Maybe Monad. Some might consider that an either monad. I don't consider it an either monad, which is something that you might also look up, or maybe I'll do a video on that, because either means there's a right and a left function, and maybe the left function is going to be an exception a lot of times, but either monad doesn't have to be that. It could be multiple different types of things on the right and left function. But this Maybe Monad is just a Maybe Monad. It happens to have an additional property on it, not a right and a left, but an additional property that will allow you to pass back an exception or exception message or something helpful to the caller. So yeah, a lot of great patterns here with that. So let me go into, that's the functional core. Let me go into the monadic service again. So this is what we were doing with the query language before. We're doing bind, a bind, a bind, and then we were doing this query language right here. Another way that you can do this is using link. So this is the same thing. It's a little bit shorter, and it's also, I would argue, better. I think easier to read, but a lot of people, if they like the function, the query syntax, then that's on them. So maybe get item. So if we're calling that repository.get item, and we're say binding the thing, and then do this. So this thing is validate num. We need the thing, so we can use its num or something. We're saying bind and do this. This bind isn't against the thing technically. This dot is technically after this. So this is binding on that number. I'm not using that number here until later on, but I'm doing like a nested bind, nested bind, nested bind, nested bind. And there's a benefit to that, which I'll tell you here in a second. So I'm binding to the thing, I'm binding to the number, I'm binding to the date time, I'm binding to this year that I'm doing here. And then the very last bind, I'm not only binding to the year and using the year, but I'm also using the num, which is in the up one level bind. I'm also using the date time, which is in the up one level bind, or whatever. I'm no longer using the thing, but I'm still within the context of the thing. And this ends up doing the same exact thing. But the difference is, if this first bind had a maybe.none coming back from the repo, it just stops right there. So we're not going to do any more processing. Maybe.none, oh, there's a maybe.none here, just stop, and then it returns back the maybe.none transferred to a string. Over here in this version, which is, some people say more readable, and that's fine. That's it's a subjective thing. But it'll do this bind, and it'll do this bind, and it'll do this bind. It'll complete all the binds, which all three of them, if it comes back as a negative thing from the repo, all three of them will end up just returning a maybe.none. So this is three maybe.nones. And then it will try the query syntax, in which case the very first one, its internal bind or its internal selection its internal flat map, if you will, it will fail. It'll say it's none here. This has none, so it'll stop here. So it will cut off early here, but it's already evaluated all three of these up here. So this is just another form that you could do where you chain along binds. So I'm going to bind this, and I'll also add in here, I can't just copy paste these because I think I can just copy paste these. So if I do this, just ends up, yeah, I'd have to refactor some of these things also. But it doesn't matter what order I do them in because of associativity. Associativity? Maybe I'm saying that wrong. So it doesn't matter which one of these three that I do, as long as I'm starting with this and ending with this, then those three don't matter. I think the reason why it errors is because of the way that the ending parentheses, I'd have to figure that out. So monadically speaking, I no longer have to check for nulls. I don't have to do try catches. I don't have to, in here, in my imperative code, I no longer have to do things. Inside of my functional core, that I'm writing my test again, I'm going to be checking for has value. I'm going to be checking for things I don't like 0. I'm going to be doing these things that make it really easy to test each individual piece. And then up here at my imperative shell, which is what I'm going to call these the top layer of the domain services that have an interface on them. At this level, I no longer need to write unit tests against this. There's a whole other talk I'm doing on unit tests and a whole other talk I'm doing about functional core imperative shell. And so I'll get into some of that in the next couple weeks. But here it is. I'm just composing together the things that I want done and the result that I want to see using the maybe monad. And versus, of course, something like this, which is really hard to test, and some might say really hard to read. Some might also say this is a lot easier to read, and so this is good enough. Some might say this refactored service, at least it's a functional core, sort of. I mean, we could pull these out into a functional core class or a helper class or something like that. I'm not saying to do that. Could be a partial class, I don't know. But this is at least refactored toward a functional core, but you're still having to do checks against things that you shouldn't have to do against. And also, if there's a problem here, then the whole method fails instead of returning monads. So benefit one is you're able to control your code flow instead of using throwing exceptions. And number 2 is you don't have to work with nulls anymore. And number 3 is you can compose your services using bind. You can compose the method you can compose the functionality that you want to happen using bind instead of a bunch of other imperative methods of doing things. Now there's more to things than bind, which I don't have on here. I'm looking at the time. I was thinking about making this a 30-minute talk, so that's mainly the portion of it, but I'm actually going to move over to another, not a half, maybe about 10 minutes worth of other talk here. Let me pull that up. That is bam, 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 bam. So in my last talk, I used this maybe demo. This demo from step to step of looking at the how a maybe monad sort of can evolve logically in your head from what our current patterns are in C# to using a maybe monad. And so what I did, this is the exact same project. If you just watch that other video, then this will look very, very familiar. Program, where I'm looking for the middle names of things. And so I've changed this. I've updated it. So if you have the repo, which is linked inside of our last video, then you'll be able to notice these differences. But for example, the person repo, I'm using that try pattern. I'm getting the single. If that fails, it throws an exception. I'm assigning that message. And then go up one level to the person service. I'm composing it. I'm saying the repo.getPerson.byId. I'm saying bind it to this functionality, and then bind it to this functionality, and that's what I'm going to return. So I'm going to return whatever the result of getting it from the repo and binding it to this functionality and binding it to this functionality. And just like in the talk that I just did, these have actual functionality in them. There may be some null checks inside of these. There may be some, in which case I'm going to be converting the null into a maybe.none, because that's actually what we want to be working with. Some null checks, some empty checks, and doing some functionality inside these. So this is where my functionality is. And then you can see, of course, I have tests against these functionality, which are all very, very simple. Very simple tests compared to, testing against a class with a method with like 50 lines in it, for example. So yeah, I actually have a channel. I actually have a meet that I'm going to post in here so that we can go over some more of this and get you guys to ask some questions and talk about the maybe monad. And hopefully the main goal of this is to clear up, the only reason you use the monad is because of null checking and and C# now has the null ability, the nullable ability. But the nullable ability, I'll point out, mainly deals with when you're passing things in or using things. So if I'm passing something in, I want to say this is nullable or this is not nullable, then the thing calling this method, it'll be a compiler error. When the thing uses this method, it'll say, it'll give you a red underline. Well, if you have warnings, treat warnings as errors. It'll give you a red underline saying you're trying to pass a null thing into a thing that does not allow null. So it's a compiler error. It's really, really helpful. It's very nice. So that nullability thing is mainly for how you pass things in. It's not for how you return things from your method. The nullability thing is more for the other direction than it is for the maybe monad direction.